Hello friends, this is Lokesh Babu. Welcome to my channel Lokesh Max Hub. Thank you for watching my videos. Friends, in this today's lecture, we are going to discuss about vector differentiation. This vector differentiation is very important and very easy to score the marks in all type of exams. Okay. So if you are serious to learn, please take pen and notebook and listen carefully. Let's start the class. So friends, in this class, we are going to discuss about gradient of a scalar function, directional derivative, and divergence of a vector function and curl of a vector function. So these are very much important, right? And simultaneously, we are going to discuss about scalar potential function, Laplacian operators, and velocity and acceleration of the particle. Now, let us define a scalar function. Scalar function means if for each value of a scalar variable t, there corresponds a unique scalar phi of t, then phi of t is called a scalar function of a scalar variable t. Say, in this vector differentiation, we have two quantities. See here, two quantities are there. Now, these are quantities. In this quantity, first of all, I will define one scalar and vector. Second one is vector. Right? Say scalar is a quantity which has only magnitude. Scalar means which has only magnitude. Whereas for vector, it has magnitude and direction. Right? If a quantity which has magnitude and direction, that is called a vector, and a quantity which has only magnitude, it is called scalar, right? So we have a lot of examples are there. For example, scalar quantity, mass is the scalar quantity, and speed also is scalar quantity, and distance, these also is scalar quantities, right? It has only the magnitude, whereas in vector, for mass, simultaneously weight is a scalar quantity, and velocity is the scalar quantity, and displacement also is scalar quantity, right? For this weight, velocity, and displacement, it has magnitude and the directions, but mass, speed, distance, these have only magnitude. That is why these are called scalars, right? Now let us define scalar function. See, if for each value of a scalar variable t, there corresponds a unique scalar phi of t, then phi of t is called a scalar function. Let us suppose phi of t equal to some x, y, z. So this is a scalar function. Next, vector function. If for each value of a scalar variable t, there corresponds a unique vector. Let us suppose f of t, then this f of t is called vector point function. So vector point function means f, capital F other small f, or capital F equal to now xi plus yj plus zk. See, if f equal xi plus yj plus zk, then we can say this is vector point function. And if it is pi equal xyz, then that is called as a scalar function. So simply scalar means without ijk, vector is with the ijk, right? Next. Say next one is position vector. See, position vector means, let us suppose this is a point, O is a point, and let A be a point. Then OA is called here the position vector. We can denote this by R bar. The position vector of a point P of x, y, z. Let us suppose here instead of A, we can write P of x, y, z, right? A position vector of a point P of x, y, z in this space, let us suppose this total space, then R bar equal to xi plus yj plus zk is the position vector. Remember, important, R bar equal to xi plus yj plus zk, which is a position vector, and magnitude of this position vector is R, or small r or capital R equal to mod of R bar, that equal under root of x square plus y square plus z square. So this is the magnitude, right? So R, just simply position vector is R equal to xi bar plus yj plus zk bar, and since it's vector, you write down I bar bar bar. Then magnitude nothing but R equal to mod of R bar. Just write down this is R only. R equal to mod R bar, that equal under root of x square plus y square plus z square, right? This is the position vector. Now, scalar point function. See, scalar point function means if each point p, x, y, z in the region R, there corresponds a phi scalar, then we can call this is as a scalar point function. In the same way, we define a vector point function also, right? The next one is very important, vector differential operator. So vector differential operator. Say this vector differential operator is denoted by reverse triangle. This is actually delta, and reverse delta this is. Reverse delta equal to, we can call this as a nabla. Okay, nabla equal to I bar I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So this is the vector differential operator. We call this as del, 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 right? So del equal to I into dou by dou x, j into dou by dou y plus k into dou by dou z. This is nabla, right? This is called vector differential operator. Very important formula. Now, gradient of a scalar field. This is very important. Gradient. Say, gradient meaning is let phi be a phi be a differentiable scalar point function. Then the gradient of a function is denoted by grad phi. Gradient is denoted by grad phi or simply del phi. You know, del value is I into dou by dou x, j into dou by dou y, k into dou by dou z into phi. That is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is called the gradient of a scalar, right? So simply grad phi equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is the, what is this? Grad phi. Okay, grad phi. Next, unit normal vector. Say unit normal vector means the unit vector, the vector which has a unit value. Unit normal vector meaning is here the vector with magnitude is 1. The vector where the magnitude is 1 is called a unit normal vector, right? So the unit vector to the surface phi of xyz at a point P is given by del phi by mod del phi. Okay, this is del phi by mod del phi at the point P equal to xyz, P of xyz. Okay, this is called unit normal vector. Okay, now so based on this, let us solve one problem. First problem is if phi of xyz equal to 3x square y minus y cube z square, then find grad phi at the point this one. So you know the formula of gradient phi or grad phi, that equal to grad phi equal to del phi. You know del value is I into dou by dou x, j into dou phi by dou y, k into dou phi dou z, into phi value is this is the phi value 3x square y minus y cube z. This is I can write I into dou by dou x of this total, dou by dou x of 3x square y minus y cube z square plus j into dou by dou y of this total again 3x square y minus y cube z square plus ij k into dou by dou z of this total again dou by dou z of 3x square y minus y cube z square. Okay, now differentiate this I into dou by dou x of with respect to x means y is 3y constant, only x square differentiation is 2x, so this is 2x into 3 6xy minus with respect to x we are doing, so no x here, therefore 0, plus j into with respect to y we are doing, y means 3x square is constant, 3x square, y differentiation is minus 1 minus with respect to y we are doing, therefore z square into 3y square into z square is there, plus k into with respect to z we are doing, this is 0, no z, so here y cube into 2z, so minus 2z y cube. So in this way you can write. Okay, so here I into dou by dou x plus j into dou by dou y plus k into dou by dou z, and after this is the values, right? Now substitute in the place of xy these point x y z value. This is x value, y value and z value. Substitute these x y z values in this given equation, you will get grad phi. Okay, now substituting this value in this equation, I into all these values, then you will get del phi value 6x yi plus 3x square y square z square j minus k into 2y cube z, where x value is 1 and y value is minus 2 and z value is minus 1. You substitute in this, for example here del phi equal to 6 into sorry, this is 6xy I 6 into 1 6 into x value is 1, y value is minus 2 and I, so what is this minus plus 6 to the 12, 6 into x value is 1, no, plus 1, so you will get minus 12i. Next plus 3x square, 3 into 1, 3 minus 3 into 1 into 12, you will get minus 9j. Then you will get this answer. Okay. So in this way, you can find the gradient of the value, gradient of a function. And the next second problem, a sphere of unit radius. Here, a sphere of unit radius means radius r value is 1, is centered at a origin. So let us suppose this is a sphere centered here and the radius is here, r value is 1. At any point of the surface of the sphere, then find the unit normal vector. You find a unit normal vector. And the equation of the sphere is actually formula x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square equal to r square. But x square plus y square plus z square equal to r is unit radius is 1. Therefore, phi equal to x square plus y square plus z square minus 1 equal to 0. And we want unit normal vector formula is del phi by mod del phi. So find out del phi. Del phi is, I into dou by dou x, j dou phi by dou y, k dou by dou into this one. Okay. So then del phi is I into dou by dou x plus j into dou phi by dou y plus k into dou phi by dou z into this phi. Now, what I can write I into dou by dou x of this total. Dou by dou x of this is only 2x you will get. So 2xi plus j into dou by I into dou by dou x plus j into dou by dou y. This is dou y plus k into dou by dou z, right? I into dou by dou x, j into dou by dou y, k into dou by dou z. Next, plus j into dou by dou y of this. So these x square are all zeros because since these are all constant. So y square differentiation is 2y plus k into dou by dou z of, with respect to z, you should differentiate this x, y, 0 and 1, 0, only 2z you will get. This is del phi. Del phi at x, y, z is 2xi plus 2yj plus zk. Now what we require? Unit normal, no? So we need a unit normal formula. What is unit normal formula? Del phi. Unit normal formula is here del phi by mod del phi, right? This is the formula. Del phi is xi plus yj plus zk. Mod is under root of x square plus y square plus z square. Okay. Leave this ijk and under root of x square plus y square plus z square. That is xi plus yj plus zk. And this value is x square plus y square z square value is unit that is 1. So I can write 1. Therefore, this is the unit normal vector. Okay. So in this way, we can find unit normal vector. And in the next video, we'll discuss about the directional derivative, very important, directional derivative and angle between the two surfaces, right? So friends, I hope you understood this video and I hope this video is helpful to you. So if you like this video, please watch, share and subscribe my channel, right? Thank you.